Here's a question no one may have asked you before. Which species is closer to the DNA of a whale? A hippo or a dolphin? Many of you would imagine dolphins. After all, both of them live in the ocean and come to the surface to breathe, right? But what if I tell you that you're wrong? A whale is closer to this than this. How does that make sense? Let me explain.
Remember these words. In nature, only the fittest survive. For enthusiasts of Darwin, this concept stands as the principle of all evolution. Either you adapt or you die. That's nature for you. It doesn't wait around for any of us, it just happens. That's the reason why snakes lost their legs, mighty dinosaurs evolved into these chickens, and of course, this land animal turned into what we know today as a whale. Oh, by the way, to answer the question, whales and dolphins are cousins, and yet, hippos are the closest relatives to whales. You see, life on Earth hasn't been the easiest. And when we talk about life 50 million years ago, the competition was even worse. The earliest known ancestor of the whale is known as Pakicetus. Yep, this little guy. Who would have thought that this little critter was going to evolve into the biggest mammal on Earth? These four-legged creatures lived near modern-day Pakistan. And for those of you with good observation skills, Pakicetus literally means whale from Pakistan. They could grow as big as 7 feet and were carnivores. This old relative of whales used to live on the land, but when your competition is with amazing hunters like Indohynodon, one had to be creative to feed itself, and Pakicetus found its bliss by hunting in water. Now, some of you may think, how on earth can the scientists claim any relation between a whale and this wolf-looking animal? And the answer is as interesting as the question. You see, when we look at the structure of the skeletons of whales and Pakicetus, we find a very interesting correlation. Their skull, around the inner ear region, has a bony wall, a feat found only in whales and dolphins. Other than that, the teeth and skull structures are very similar, and the most important fact is that Pakicetus lived near water bodies and used its denser limbs to even catch fish from them. Interestingly, the Pakicetus is believed to be the first cetacean, which can be understood as the forefather of all marine mammals. It was during the Eocene epoch period, so it further establishes the fact that the animal found itself better suited to water. Also, the climate was heating up during that time period. Everything started to connect for little Pakicetus. Water was the answer for everything, be it hotter temperatures or the shortage of food. So this ancestor of whales took the boldest decision. It started living closer to water, and with time, nature did what it does best. The magic of evolution began. A small mammal changed its lifestyle, and what followed became the biggest case of evolutionary distinction. In 1971, Indian geologist A. Runga Rao, while collecting rocks, found odd remains of teeth, and upon further investigation, unearthed the remains of a very interesting species, later named Indoyus. Now, the evolution of whales will be incomplete without mentioning this relative of Pakicetus. You see, Indoyus can be explained as that distant cousin who's a part of your family, but none of his characteristics match yours. Both of you are from the same family, but you have your differences. After all, Indoyus was a herbivore. Do you know about a modern animal called a chevrotain? It is also known as a mouse deer. It is claimed that chevrotain is a direct descendant of Indoyus, which was among the first creatures that hid in water whenever it was threatened. The chevrotain can also do that today, which is also a herbivore that can spend over 5 minutes underwater when it is trying to hide from predators. This feat to spend a long time underwater, and the fact that Indoyus's remains were found in Kashmir, that is in modern-day India, further establishes the connection between the two species. So, a school of thought believes that cetaceans began from this herbivore family, but shifted their lifestyle to adapt a more carnivorous diet, which caused 2 different families of species to evolve from the same family. One became a smaller deer-like animal that is a herbivore and hides in water when threatened, and the other became a carnivore that evolved into modern-day whales. However, this thesis is not accepted by all the scientists, as some others suggest that the ancestors were omnivores. The existence of Indoyus in the whale family tree may be debatable, But the community almost unanimously agrees that Pakicetus was indeed the ancestor. About 49 million years ago from today, another species emerged that is regarded as the evolution from Pakicetus. Introducing Ambulocetus, which means the walking whale. It was first found in the Kalachita Hills of Pakistan around 1992. As the Pakicetus started to spend more time underwater, the usage of legs became insignificant. So, slowly but surely, its legs started to evolve into something that would be more useful in swimming than in walking. It is believed that Ambulocetus was the first ancestor of whales that had webbed feet. Its forelimbs were enlarged like paddles, while the hind limbs were shorter, which means it used the forelimbs for swimming, and the legs were getting shorter as it did not walk on land a lot. Further, the tail of this animal became stronger, which means it could use it to swim and propel itself further. It would not be wrong to claim that Ambulocetus had evolved into an aquatic animal by this point, as it had less to no land activity. However, we still claim it to be an amphibious animal, not marine just yet. Some scientists even claim that this species would not be able to support its own weight on land.
It should also be noted that the size is increasing with each evolutionary phase. The Ambulocetus is known to get as long as 10 feet. So we're getting closer to the colossal target of 100 feet long for blue whales, slowly but surely. However, the most important part about Ambulocetus's discovery is the fact that this animal could even live in salt water as well. You see, when scientists study a skeleton, they can deduce the type of water the animal could survive on by studying the isotopes of oxygen. And they found that Ambulocetus consumed both freshwater and saltwater, which is another giant leap forward in evolution. It is also believed that during this phase of evolution, the Ambulocetus learnt skills that would make it more suitable for an underwater lifestyle, including evolution in its ears, which would later evolve further in a way that nowadays whales can feel sounds. Even though this was not the perfect phase in the evolution of whales, who would think of a fish with feet with no use? Ambulocetus was an integral part in the bigger picture. The animal learnt useful characteristics that would only help it in the future, be it the ability to listen underwater or reorganized body parts for better swimming. But we still have a long way to go to reach what we know today as whales, over 40 million years to be precise. Now the creature is taking the shape of what you can call a whale. The legs are almost non-existent, and the fins are coming up. Introducing the next stage in the amazing evolution of whales, the Remingtonocetidae. Let's go back in history a little bit. About 40 million years ago, it seems the ancestors of the whales have found themselves a good abode in the depths of the ocean. With time, scientists have found remains of multiple Remingtonocetidae in a more distributed manner than any other ancestors. And the best point to notice from this stage of the evolution is the fact that Remingtonocetidae didn't depend on fresh water at all. That's right. When samples from the skeletons were extracted, scientists noticed that there were stable oxygen isotopes, which further establishes that this creature didn't rely on freshwater sources. A small fact, but definitely a giant leap for the evolution of the whales. Well, let's just say it's thanks to Remingtonocetidae that we don't find massive whales in our rivers. But that's not the end of the story, as we will find out later. But the ditching of freshwater isn't the only feat this creature brought to the lifestyle of whales. It also introduced some major changes in the morphology of the creature as we know it today. For starters, this creature was more streamlined, which further makes it more of an aquatic animal than a land mammal. Here's a fun comparison. If you want to understand what the Remingtonocetidae was like, just imagine a crocodile. Yep, that's about it. It is a long animal with long and narrow stout and conical teeth that lives in the water, but for some reason also has legs. Even though, unlike crocodiles, this animal never went on land. Evolution can be crazy sometimes. Iconically enough, this is the stage that scientists claim was the point of no return for our land animal turned fish friend,
They say that evolution had brought them so far that they just couldn't survive on land anymore. So the fate was sealed for whales to be aquatic animals when they took the form of Remingtonocetidae. This is further established by the fact that the inner ear canals, essential for balance in mammals, were shrunk to an almost non-significant size during this time period. Hence, it's safe to conclude that this ancestor of whales, the Remingtonocetidae, had given up land completely and started to adapt to its relatively newfound territory, the ocean. Around this time, the species still hadn't taken the massive size, as the Remingtonocetidae were still about 4 meters long, which is nothing compared to the Goliaths some species of whales can become. Another fun fact about this species is its name, which may seem a little out of place. After all, so far we've heard names inspired by the places the species was found in, right? Well, Remingtonocetidae is named to pay homage to Remington Kellogg, a famous paleontologist who worked extensively in the marine world. So far, we have been limited to the Asian regions only, but this ancestor was different. Now, we're going global, because now we're talking about Protocetidae. So, about 38 million years ago from now, these species took another step forward in becoming aquatic when compared to Remingtonocetidae. The Protocetidae were the brave ones that took the whale family to global stages, which include Asia, Europe, Africa, South America, and North America. As per many reports, their skeletal remains have been found in almost all shallow subtropical oceans of the world. But that's not the only progress that this aquatic animal made. Let's tell you about it all. For starters, their eyes, or more specifically, the orbital bones, which means the area of the skull where eyes exist, were larger and took a rather more lateral orientation. This means that the morphology became more suited for underwater hunting, as their eyes could see better in the darker environments of the ocean. Moreover, they also ignited the most recognizable feature of any whale, their blowhole. The nasal openings of the Protocetidae were very large and made their way up the snout, which is a nod to the modern-day whales. So, not only did this creature reach a larger area, but had some signature features that make whales what they are today. But that's not all, because the hearing capabilities of the mammal also got some serious upgrades. After all, land animals can't rely on their conventional ears to hear underwater, can they? You see, in the case of protocids, the mandibular foramen, which is a part of the jaw, got a lot bigger. And yep, you're asking the right questions. Jaws do help in hearing when you're underwater. So this part of the jaw has a special fat pad that helps to carry sounds from the environment to the ear, hence making a more reliable hearing system for the mammal. However, this was still not the best method to have the sense of hearing. As the protocetids could hear, they just couldn't tell precisely where the sound was coming from. And more than that, they couldn't even differentiate between the different types of sounds, so it was more of a prototype stage than anything else. Whales nowadays have much better systems, where they can even use it for hunting, communication, or even singing songs in some cases. Yep, you got that right. Many species of whales, like the humpback whales, can even sing complex songs that have repetitive hooks. Isn't that insane? However, the protocetids did still have the limbs from before, which is still insane to think about. It is debated that they still used to come to the surface at times, but the motion on land wasn't the best. Scientists claim that it would have looked like what a sea lion does when walking on the surface of land. Its back legs just weren't built for land, so it just waddled around on land, swinging its flippers underneath to move. But the ability to come ashore doesn't mean that the protocids did do that. But one thing is for sure, the next stage didn't have that ability at all. Now let's come to the most acclaimed final form of whale ancestors before they took the form we know about today. Introducing Basilosauridae, the most complete whale before whales. Not only the progress in terms of the body structure, but these guys were also the first relative of whales to get that massive size. According to reports, the Basilosaurid could even be as long as 60 feet. It must have felt like discovering a king serpent fossil when the paleontologists dug this one up. They swam the great oceans of Earth about 34 million years ago and were also the ancestors of whales that didn't have long legs. Their forelimbs had taken the shape of fins and looked exactly like an aquatic animal, so no more double life. Their hearing also got an upgrade. Remember how protocetids could listen but couldn't tell the direction? Well, not anymore. The hearing parts of these creatures were further developed, which meant that they could listen and judge the directions of the sound accurately.
However, as you could tell, we are still very far from having the perfect form. For starters, this creature didn't have a special part, called the melon organ, that helps the whale to perform echolocation. The melon organ is a lump of adipose tissue found in the forehead of whales that helps them to communicate and have a better sense of hunting and direction thanks to echolocation. Further, many scientists claim that this species didn't have a sophisticated social life because it didn't have a developed brain. Essentially, they claim that the basilosaurids didn't have a social life because they had a small brain. Why does that sound like a roast? Well, you must know that whales are among the most social animals right now that depend a lot on their society. This means that they live in groups, travel in groups, and even hunt in groups. But based on the evidence, basilosaurids were rather lone hunters. Massive lone hunters. You see, the basilosaurids could reach as long as 60 feet in size, which is a crazy feat when you compare it to the earlier species. When you are in the ocean, size doesn't end up being a problem. After all, the oceans are massive themselves. The reason behind the massive size is the increase in length of their spines, more particularly the lumbar vertebrae. That's why many sources claim the basilosaurids to be the closest and the most perfect ancestor of the whales. Another fun fact about the basilosaurids is that even though they had very underdeveloped hind limbs, after all, they didn't need feet, they did serve a rather important purpose. Scientists believe that basilosaurids used their hind limbs to clasp onto their partner while they were mating, which is quite something. I'd let you guys comment on it, so feel free to show your thoughts down below. Now let's finally understand what whales have become. Remember when we came from this little fella? Well, if you give nature a good 50 million years, who would have thought that it would look something like this? Isn't that crazy? Now, the evolution cycle has one last trick up its sleeve, and divided the modern whales into two categories: toothed whales and baleen whales. And to make you understand it better, here's a visual representation. Let's tell you about the baleen whales first. Now, let's go back to the Finding Nemo clip. Did you notice that the whale didn't have teeth? Instead, it had a special set of evolved keratin structures that act as filters, or a massive strainer. For those of you who don't know, keratin is a protein found in human hair, so it's essentially a mouthful of hair. These whales just open their mouths, essentially drink gallons of water at once, then use the baleen to filter out tons of tiny krill, plankton, and even tiny fish that get sucked in with the water.
The baleen group of whales includes the largest mammal we all know. That is the blue whale, humpback whale, right whale, and also the bowhead whale. And these guys are also responsible for the whale songs that you need while sleeping. They can sing, and their sounds can reach hundreds of miles throughout the ocean, making their community highly efficient in social responsibilities. Also, the endless supply of food, and not having to work hard to find food and chase to hunt, their bodies became massive over time, where the biggest ones can get as heavy as 200 tons. And yes, unlike their ancestors, the brains are big enough to understand the concept of society, and they are social beings, which makes them even more advanced. But that sense of society becomes even more dangerous in the case of toothed whales, where we're talking about orcas, the deadliest whale, and some others, including dolphins. Isn't that insane? Their boon is echolocation, which makes them amazing hunters without relying on sight. You see, when you go deep enough in the oceans, even light from the sun can't reach the depths, and that's when echolocation comes in clutch. Toothed whales emit rapid clicks and wait for them to come back after striking a surface. They are then able to calculate and estimate the possible location of their prey, even in pitch-dark settings, which is just deadly. Remember how the early ancestors of whales were trying to get rid of surface hearing to be able to hear underwater? It's almost poetic how that has become something so fundamental, yet advanced in the lives of the descendants. And while we're on the topic of brains, it's worth pointing out that toothed whales have some of the largest and also the most complex brains in the whole animal world. Everyone knows that dolphins are second to humans when it comes to the brain size to body size quotient. We've seen dolphins asking for help, and we've also seen them performing complex tricks to get some treats.
It's safe to say that the evolution of whales has come a long way. Orcas and dolphins are considered to be some of the smartest animals in the world, so that tells us something about their evolution as well. Not only that, but orcas are also the world's deadliest hunters. They travel in groups, and they even hunt just for fun. They have tactics of luring their prey, playing with them even after their demise, and then, to make it all worse, some dolphins have also been found to abuse others. So while the baleen whales are the gentle giants of the family, it won't be wrong to call the toothed whales the troublesome cousins. While the baleen whales are not that fond of hunting, the toothed whales enjoy it a little too much. They are very skilled hunters, orcas being named the best of all. The former got a skill that helps them to eat without much worry. The latter, the toothed whales, got a skill that makes them the deadliest hunters, which is the echolocation.
Another key difference between the two is the fact that baleen whales have 2 blowholes instead of just 1. You see, land animals have 2 nostrils, and that somehow also ended up following the baleen whales, and hence ended up becoming 2 blowholes instead of 1. Whereas, in the toothed whales, one of the blowholes evolved and became the part that's necessary for echolocation. So yes, massive differences between the two, which makes the evolutionary process even more interesting and intense.
So, let's end this video how we started it. Remember when I asked you at the start which animal is closer to a whale's DNA, a dolphin or a hippo? It's finally time to answer that little brain teaser. You might still be thinking about dolphins because same habitat, both breathe air, both look like sleek ocean athletes. But here's the truth. The closest living relative to a whale is a hippo. Now, I know that sounds ridiculous. One's a 150-ton marine giant with a song that can travel hundreds of miles, and the other is a grumpy semi-aquatic tank that yawns like it's trying to swallow the horizon. Not to mention the cute offspring that go viral. I'm talking about you, Mudeng. So how does this connection even exist? You see, scientists have known for a long time that whales are mammals, which means they're warm-blooded, give birth to live young, and nurse them with milk. But finding their closest relative took more than just looking at the family tree. It took looking at the family bones and a little DNA work. In the 1980s, researchers were comparing DNA sequences of various mammals and found something bizarre. Whales shared a surprising number of genetic markers with a group called artiodactyls, or even-toed ungulates. This is the group that includes cows, pigs, camels, deer, and, yes, hippos. But here's the plot twist. Not all artiodactyls are created equal when it comes to whale DNA. Hippos turned out to be their VIP cousin, and the DNA match was so close that scientists eventually placed whales and hippos into their own subgroup called whippomorphs, which, let's be honest, sounds like the name of a terrible 80s rock band. Well, about 55 million years ago, whales and hippos had a common ancestor, and we have to go even before what we have discussed in this video earlier, a 4-legged semi-aquatic creature that probably looked nothing like either of them today. This ancestor lived part of its life in water and part on land, much like modern hippos. Over millions of years, 2 branches emerged, one that stayed closer to the land and evolved into hippos, and another that dove fully into aquatic life, eventually becoming whales, as we have just discussed. It's almost poetic when you think about it. The hippos stayed home, guarding their riverbanks, while their cousins swam out to sea and decided, yep, this is it, I live here now. Evolution really is like a family reunion. Some relatives stick to their comfort zone, others move halfway across the world and start eating krill for breakfast.
But the similarities don't stop at DNA. Hippos and whales actually share several very specific traits that other mammals don't have. For example, both produce the same kind of milk protein. Both also have similar ankle bone structures. Yes, ankle bones, even though whales don't use them anymore. In hippos, the structure is still functional for walking in shallow water, but in whales, it's a leftover evolutionary souvenir, buried deep in their anatomy. And then there's their ears. Hippos and whales both have dense bones around the inner ear, which helps them hear underwater. In whales, this evolved into one of the most sensitive underwater hearing systems in the animal kingdom. While in hippos, It's just handy for picking up splashes and rival grunts. Also, both species have nostrils placed high up on their heads. In hippos, this means they can breathe while mostly submerged, and in whales, it evolved into the iconic blowhole. Now, I know what you're thinking, but hippos can't sing whale songs, which may be true until you count that terrifying rumble they make when they're annoyed. In fact, both animals actually communicate underwater, just in very different ways. Whales use songs, clicks, and pulses. Hippos use subsonic grunts that can travel through water. It's a bit like comparing a symphony to someone shouting across the pool, but the principle is the same. Here's another twist. Hippos are surprisingly aquatic for being land mammals. They can hold their breath for up to 5 minutes, and calves are even born underwater. Sound familiar? That semi-aquatic birth style is exactly the kind of life their shared ancestor likely had, long before whales evolved into the ocean giants we know. So to sum it up, whales and hippos are not just distant cousins on some dusty evolutionary chart. They're each other's closest living relatives, connected by DNA, bones, and a shared ancestor that decided water was worth the trouble. The whales took the all-in approach, evolving fins, tails, and sonar. The hippos went with the half-in lifestyle, sticking to rivers and lakes, but still keeping a few family traits from their oceanic cousins. It's a strange thought, isn't it? The next time you see a hippo yawning lazily in a river, you're actually looking at the closest thing we have on land to a whale. They may not look alike, but deep down, pun intended, they are kin. And here's the part I love. This connection between two wildly different animals is a reminder that life's family tree is full of surprises. You can't always tell where you come from just by looking in the mirror. Sometimes, your closest relative might be living in an entirely different world.
So there's one thing to take away among all the information we've just served out. The whole process of evolution can be very insane. We've come from a weak land animal that hid in water to protect itself from predators, to a massive being that can chug up to 15,000 gallons of water, and the same being that had some changes in lifestyle took the shape of nature's most intelligent and brutal hunters, and it all started from this. This is the insane evolution of whales. And you know the best part? We're not even done yet. This giant is still evolving, and what it becomes will only be known by our descendants millions of years from now.